Hello everyone, welcome to Chemazon-Complete Chemistry. In today's video, we're going to solve another question from the NET 2024 June paper, that is from steady state approximation, that is a topic of chemical kinetics. So the question is, reactant A getting converted to product P consists of three elementary steps. First is, these are the three steps that are given. We have to find out the activation energy of the overall reaction. So the first fundamental thing that we must know is what is the rate determining step. Okay, rate determining step or RDS is the slowest step. Okay, because the rate of the reaction will depend on this step, because the overall rate of the reaction cannot be slower than this step. Okay, that is why the slowest step is the rate determining step. So they have given three reactions. Here you can see the third one is the slow step. So we'll write down the rate equation for the third equation, that is rate of formation of product P, okay, dP by dt is equal to, so let us first assign some rate constant for all these three equations. Okay, A getting converted to intermediate I, let's say rate constant is K1, I getting converted to A, let's say this is K2, and I getting converted to product P, that is K3. Okay, so for the third reaction, what is the rate constant? It is K3. So let us write that K3 into reactant is I. Okay, that is the intermediate. Now, can we find out the intermediate concentration? The exact concentration of intermediate? The answer is no. Why? Because it is short-lived. Short-lived means it is, sometimes it is stable, but it stays for a very shorter duration of time. So that is why we cannot find out the exact concentration of the intermediate. So what we apply? We apply something called as a steady state approximation. Steady state approximation. Okay, and what does this state? A steady state approximation states that the rate of formation of the intermediate is same as that of the rate of formation of the rate of consumption of the intermediate, or we can say decomposition of the intermediate, that is equal to 0. So this is the steady state approximation. Now we have to apply this. Okay, so in which step the intermediate is getting formed? In, let's say, let us number this 1, 2 and 3. So in first reaction, intermediate is getting formed. So what will be the rate for that? How do you write down the rate? Okay, rate of formation of the intermediate, that is going to be di by dt. Okay, di by dt, that is equal to where it is getting formed in the equation first. So it is the rate constant of equation first is K1. Okay, into the reactant is A. Okay, now in any other step intermediate is getting formed? No. In second step it is getting decomposed or consumed. For consumption we write, here we are writing the rate of formation, plus means rate of formation. So for decomposition we add a minus sign. Okay, minus, what is the rate constant for the second equation where intermediate is consumed? K2. So write K2 into reactant is what? Reactant is I. Okay, so rate of formation minus rate of decomposition, overall it is equal to 0. Okay, according to this statement, if I want to rearrange, it will become same. Okay, this is rate of formation of the intermediate is equal to this negative on the right hand side, it will become positive. Okay, so rate of formation is equal to rate of decomposition. Okay, so rate of formation minus consumption is equal to 0, that means rate of formation of intermediate same as that of rate of consumption of the intermediate. Okay, now what we have to do is we have to substitute this concentration of the intermediate. So what will be I? I will be rearranged. This is multiplication. Here it will become division. K1 divided by K2 into A. Okay, so now we have two equations. This is equation 1. This is equation 2. So substitute 2 in 1. Substitute 2 in 1. Okay, what we will get? I'll write here. Okay, rate of formation of the product dP by dt is equal to K3 is already there. Okay, I is what? K1 into K2. So K1, okay, into K2 means divide by K2 into A. Okay, so this is the final rate of the formation of the product. Okay, now always remember to find out the overall activation energy. Okay, let's say EA overall. How do you find out? Always remember, whenever the rate constants, okay, it is in multiplication. Okay, there is multiplication. Then for the activation energy, what you will do? You will add the activation energy, and whenever there is division in the expression of the rate constant, you will, for EA you will subtract. Okay, if it is multiply, you add. If it is divide, activation energy will be subtracted. Okay, so here you can see first is K3. So I can write EA3 multiplication means you add. Add what? Add K1. K1 means EA1, activation energy of the first reaction. Okay, then you can see there is divide. So you write minus. Okay, then there is K2. So you write EA2. Okay, so this is the overall expression of the activation energy of the overall reaction. 3 plus 1 minus 2. So minus is EA2. So what is the final answer? Final answer will be option 4, EA1, okay, plus 3 and minus 2. Okay, first option all are plus, incorrect. Second option EA3 is minus, that is also incorrect. Option 3 is also incorrect. So the only correct answer will be what? Option 4. Okay, I hope you have understood the solution. Okay, this is the application for SSA, that is steady state approximation. This type of question based on SSA is most often asked in NET exam. Almost every exam they ask at least 1 or 2 questions. I hope you have understood this. Thank you.